Hello and welcome to another Arlington High School Math 4 Honors lesson. My name is Kirk Weiler and today we're going to be doing Unit 3, Lesson Number 1 on Introduction to Limits. Limits are the basis of all calculus. They lie behind every single one of its major branches, so obviously it's kind of a big topic. And we're going to be spending the entire Unit Number 3 talking about limits. So today, as we set them up and we understand their notation, and what they mean and how to evaluate them, primarily graphically, all right? Pay very, very close attention. Every little detail counts in calculus, and underlying all of calculus, again, is this idea of a limit. So let's take a look. All right. In exercise number 1, I have a piecewise function graph for you, and I gave you its formula, but honestly, the formula here is not all that important. And it's in green. I'm going to switch back over to blue. All right. Letter A, whoops, sorry about that. Letter A asks, what value is the function heading towards as the x value approaches 1 from the left? So here's obviously x equals 1. It's an important place. It's where it breaks. So as x is approaching 1, what value is the function approaching? Pause the video for a minute and think about that. Well, it looks like the function is approaching 5, right? And that would be the answer to the question, but I'm going to introduce some notation right here. What I would say is I would say that the limit of f of x as x approaches 1 from the left is equal to 5. I know that's a little negative sign, but it means from the left. From the left. Now remember, one thing that's very, very critical here is that when we talk about the function, we're talking about the output of the function, which is the y value. All right? Now please note that f of 1 is equal to 5, but this, and I can't say this enough, is irrelevant. The fact that the function's value at x equals 1 is 5 is irrelevant. It does not matter. All right, well, letter B asks a very similar question. It says, what value is the function heading towards as the x value approaches 1 from the right? So now here we are, we're walking along the x-axis, right? Which means on the curve we're heading down like this. And as we get very, very, very close to 1 on the right, what value is the function headed towards? Well, it's heading towards a y value of 2, right? The limit of f of x as x goes to 1 from the right is equal to 2. All right? Now again, f of 1 is equal to 5. So we never get to a y value of 2, but let's really try to nail this down. The limit of a function is where it's headed towards, where the y coordinate is headed towards, as the x coordinate heads towards some other value. It is not necessarily where the y value ends up. So we all know that f of 1 is equal to 5, or at least we need to know that f of 1 is equal to 5. But it's heading towards 5 only from the left. From the right, on the other hand, it's headed towards 2. Okay? Very, very important. It's not about where the function ends up. It's about where the function is headed towards. All right? Pause the video now if you need to, and write down anything you have to. All right, let me clear out the text. Let's continue. So, to test whether or not you really understand this idea, right, I've given you a much more complicated looking function in number 2. So this is the graph of y equals g of x, all right? And I ask you a bunch of different limit questions. Let's do A and B together, and then have you do the rest of them on your own. So letter A says, what is the limit of g of x as x approaches negative 2, and again, that little negative sign there means from the left. Now the best way to do this in my mind is you come over here to negative 2 and you start approaching negative 2 from the left. And the question is, what is this function headed towards? Well, it's headed towards a value of 3. Does it reach a value of 3? No, no it doesn't. All right, but it's heading towards a value of 3. And that's what the limit is, where you're heading, not where you end up. Now, as you head to 2 from the right, this is a little bit trickier, or maybe it's a little bit easier, I don't know. You're along this portion of the curve. Now, what's weird about that is that that's a constant, right? And it happens to be the constant 5. So not only is it where you're headed, it's sort of where you are, so to speak. Okay? So why don't you try the rest of them? Okay, write down whatever you think is correct, and if you're not sure, leave it blank. Okay? Pause the video now. All right, let's go through each one of them. Here, letter C, we're headed towards 1 from the right. Okay? Which means we're doing this, which means we're climbing this curve, doing this, and it appears that g of x is headed towards 3. On the other hand, if we're headed towards 1 from the left, then we're on this curve, and again, since it's horizontal, it looks like we're just headed towards 5. Now notice, g of 1 is undefined, or doesn't exist, either way. Undefined or doesn't exist. So we can certainly have a limit, even when the function doesn't exist at a particular value of x, which means, of course, that value of x isn't even in the domain. All right, let's take a look at a couple that are definitely confusing. I'm going to just erase this text like this so that we can see it a little bit better. Here it says, what's the limit of g of x as x approaches 3, again, from the right? All right, 1, 2, 3. Well, here's x equals 3. And if I'm approaching 3 from the right, then what happens is I'm heading up this curve. Now, that dashed line from last year, right, that's a vertical asymptote, which means that the function is headed towards infinity as x goes to 3 from the right. Now, as x goes to 3, though, from the left, right, so here we're coming in this way, then we're headed downward, and we're headed towards negative infinity. Okay? All right, let's look at one last one. I'm going to do a little more erasing. Sorry about that. All right. Here, I'm looking at what's going on as x goes to negative 3 from the left. All right, well, what's going on here? Well, we're heading up, heading up, heading up, heading up, and it looks like we're heading to a y value of 1. Likewise, as we head into negative 3 from the right, we're also heading to 1. All right. I really, in letter G and H, just wanted to point out that these, what are known as directional limits, can be different, as they are in A and B, C and D, E and F, or they can be the same, right, as they are in G and H. Actually, the vast majority of the time, they're the same, even though I've given you a lot of examples where they're different. All right? So, again, the limit is where the outputs to either a function or an expression are headed as the inputs get closer and closer to a certain value, what's known as infinitesimally close. Infinitesimally close. And again, you'll hear me use this term a lot, infinitesimally close. Infinitesimal means very, 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 very small, but not 0. So infinitesimally close means we're getting really, really, really close to negative 2. We're just not at negative 2. Okay? So there's your idea. Okay. Pause the video now and write down anything you need to. All right, I'm clearing it out. Let's do another one. Actually, let's not do another one. Let's talk about a bidirectional limit, or an ordinary limit. All right. So before, we had all these limits where, x was going to a number from the right, or x was going to a number from the left, right? And that was a little bit confusing, right? Did you notice that, it's kind of confusing to talk about a rightward limit because you're moving to the left, right? I mean, when you're coming into a number from the right, you're actually moving to the left, which I've always found a little bit confusing, but it is what it is. Now, in many cases, what we're going to want to do is we're going to want to be able to drop that little plus and that little minus. So we're going to say that the limit of f of x as x goes to a, no plus, no minus, exists if and only if the limit of f of x as x goes to a from the right is equal to the limit of f of x as x goes to a from the left. So just from that previous problem, all right, so you don't have to flip the sheet over, or you can flip the sheet over and look, right? You know, in the case where we were looking at x going to 1 from the right, right? From the right, we were headed to 3. From the left, we were headed to 5. Now, because those two are different, we would say that the limit of g of x as x goes to 1 does not exist. It just doesn't exist, all right? The only way it can exist is if these two things are the same. On the other hand, when we were sitting here at -3, right, and we came in from the right and we came in from the left it ended up going to 1, from the right it ended up going to 1. So we could say that the limit of g of x as x goes to -3 exists, and it's equal to 1. All right? Now this is really just a definition. It's just really notation. I'm able to say that a limit exists, a bidirectional limit exists. I can get rid of the little plus, the little minus, if the two directions are headed to the same location. Do they have to get there? No. It's not about getting there. It's about where you're heading towards, Okay? So pause the video now and think about this a little bit before we move on to the next exercise. Okay, I don't know if you can hear the clapping in the background. I think that's a chemistry classroom somewhere nearby. I'm going to clear it out. Let's keep going. All right, so another piecewise function. Terrible looking formula, and really the formula is somewhat irrelevant here. What's relevant is the graph. And what I ask you to do in A and B is evaluate a bunch of directional limits. Since we've already done that already, I'd like you to do it on your own. So pause the video and see what you can do. All right, let's go through A and B. So in letter A, it says the limit of f of x as x approaches 0, again, little reminder from the left. So if I'm at x equals 0, and I'm approaching it from the left, the output of my function is approaching 2. On the other hand, if I approach x equals 0 from the right, the output of my function is approaching, not 5, how about 4? Let's try that again. 4. All right, likewise, let's say that we're approaching 4. 1, 2, 3, 4. Right? If I'm approaching it from the left, right, the value is getting closer and closer to 1, 2, 3, 4, 5, 6, 7, 8. It's getting closer and closer to 8. And if I approach it from the right, it's also approaching 8. Please note that f of 4 is equal to 3. By the way, I know that based on two things. F of 4 is equal to 3. One thing I know is because there's a dot there. The other thing I know is because it's sitting right here. There it is, right? When x is 4, y is 3. But that has no bearing at all on the limit. And again, I know I've said this a few times already in this video, but it bears repeating again and again and again. The value of the limit has nothing to do with the value of the function. Now, are they sometimes the same? Sure they are. In fact, most of the time they're the same, but that's boring. In the situations that are important and interesting to us, the value of the limit and the value of the function will not be the same. Anyway, let's take a look at letter C. It says, does either the limit of f of x as x go to 0 or the limit of f of x as x go to 4 exist? If so, what are the values? And if not, why not? All right, we'll pause the video, think about this a little in light of what we talked about. All right, let's go through it. Well, this one does not exist. Why? Because the limit of f of x as x goes to 0 from the left doesn't equal limit of f of x as x goes to 0 from the right. They just don't equal. But this one does. Yes, that one does exist, and in fact we can say that the limit of f of x as x goes to 4 is equal to 8. Right? I just know that now. Because coming from the two sides, they're both approaching 8. Do they reach 8? No, but yet again, irrelevant. As I get infinitesimally close to x equals 4, if I blew that graph up, right, and I was sitting right here, and I was sitting right here, I would be very close to an output of 8. Okay? Very important problem. Pause the video now and write down anything you might need to. Okay, I'm going to clear out the text. Let's do one final problem. All right, exercise 4. Given f of x equals the square root of x plus 4 when x is less than 0, and 6 minus x when x is between 0 and 6, sketch a graph of the function below. Letter B, are there any points where the right limit exists but not the left limit? Explain. All right. Well, what I'd like you to do is pause the video right now, get some practice sketching a piecewise function. We did that recently. Let's see if you can do it here. All right, let's go through it. So, I'm going to get me some axes. Faster anyway. All right. Remember how I talked to you about sketching piecewise functions? What I'm going to do is I'm not going to worry about the domain interval, not too much. Root x plus 4 is the square root function shifted 4 units to the left. Now what may be helpful is knowing that it intersects the y-axis at 2. Oh, this is going to be poorly scaled. I'm going to get rid of this real quick. We'll take another shot at this. Good. One more time. You'll see why. Okay, real quick. 1, 2, 3, 4. Remember, I draw it in dashed. And then I say, well, that's only good for x is less than 0. So something like that. But it would be good to know that this is at 2. Now, 3, 4, 5, 6, right? 6 minus x is the line that does something like this, right? And it actually intersects here at 6 as well. Think about that for a second. And that's where we take off, right? So that's in our filled in portion. Boy, that is a lovely looking line. Sorry about that. That's not making the situation any better. Okay, there's my very poorly drawn graph. Let's take a look at letter B though. Are there any points, x values, where the right-hand limit exists, where you can come in from the right, but not the left limit? Just exists, right? Just exists. So are there any points where the right limit exists, but not the left limit? Explain. Well, pause the video now and think about this in light of what we've talked about in this lesson. All right, well, let's talk about it. A lot of people mistakenly say x equals 0. So this is wrong. I want to very much emphasize this. This is wrong. Okay, but they'll say that because they'll say, well, look, I mean, you know, if you're coming in from the right, look, that's a filled-in circle, and if you're coming in from the left, that's an open circle. Nah, that's wrong because the limit of f of x as x goes to 0 from the right exists, and it's 6, and the limit of f of x as x goes to 0 from the left exists, and it's 2. So those both exist. So is there any x value that you can approach from the right and get an answer, but you can't approach from the left? Again, pause the video now to see what you think. All right, let's go through it. So the correct answer is x equals -4, right? So that's easy enough because the limit of f of x as x approaches -4, but from the right, here's my -4, is going down, 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 down. It's equal to 0. But the limit of f of x as x approaches -4 from the left, well, that does not exist. And the reason it doesn't exist is that there's nothing out here. Nothing here, right? There's nothing there. So if we get infinitesimally close, right? If I were to draw out my number line, here's -4, right? Here's my curve that way. If I got very, very close to -4, but on the left, there's no function there. Therefore, it doesn't exist. All right, and that's important because where functions begin and end, you can't have a normal limit because there's no way to come at them from the outside, so to speak. All right, well, pause the video now, copy down anything you need to, and then we'll finish up the lesson. All right, clearing out the text. Let's finish up. So, I may have mentioned this at the beginning, limits are the basis of all calculus, because they deal with infinitesimal quantities. The idea is both easy and difficult to understand at the same time. The limit of a function, or the limit of an expression, is where the outputs are headed towards as the inputs get infinitesimally close to some value. All right, we can approach limits from the right, we can approach limits from the left. If those two values are giving us the same thing, then we just say it's the normal limit, no little plus, no little minus. And if they aren't equal to each other, well, then the normal limit doesn't exist at all. All right, well, I want to thank you for joining me for another Arlington High School Math 4 Honors lesson. My name is Kirk Weiler, and until next time, keep thinking,